They want us to convert 68.3 centimeters cubed to cubic meters. So anytime you have information with one unit and they want you to express that same quantity in a different unit, so you don't want to change the quantity, that means you're going to be multiplying by factors that are equal to 1. So the quantity doesn't change, but the unit will change. So we need a relationship between those two units. So in the metric table that is in the book and on the formula sheet, there is a relationship. Anytime you have a base unit in the metric system, the base unit has a power of 10 that's 10 to the 0 power, which is equal to 1. Right? Our base unit is just standard power of 10, or 10 to the 0th power, which is equal to 1. So then when you see the prefix in front of that base unit, the prefix tells you what power of 10 that unit represents. And so for centi, that is 10 to the negative second, which you could also express, outside of scientific notation as 0.01. So for me, I think this is easier because all you have to do is look at the power, not the number 10, or you don't have to move the decimal some number of places to figure out what's going on. You just look at the power that the 10 is raised to, and that tells you the difference or the relationship between these two units. So 10 to the 0th related to 10 to the negative 2, that's a difference of 2 powers of 10, right? To go from 0 to negative 2, the difference is 2. So that's 2 powers of 10. So that means if I want to relate centimeters to meters and make them equal, the relationship is 2 powers of 10. And so anytime I'm working in the metric system, if I make that power of 10 relationship positive and put it with the smaller unit, then my relationship will be equal. Right? So what I mean is, since the difference here is 2 powers of 10, I'll make that a positive 2, and I'll put it with the smaller of the two units, and I know the centimeter is smaller than a meter because it's down near the bottom of the chart and it has a smaller power of 10 associated with it. Right, so the point here is I'm trying to set these two units equal. I'm trying to show the relationship that makes them equal. So a centi is smaller, which is why it takes a large number of centimeters to be equal to 1 meter. So 10 to the second, or 100 centimeters, equals 1 meter. Does that seem right to you? Yeah, centimeters is a short distance and meters a longer distance, so it takes 100 of them. So now that I know that relationship, it's not going to really totally yet help me make the conversion I want, because I need a relationship that relates centimeters cubed to meters cubed. So if I know this relationship, though, and I've got an equation where the left-hand side and the right-hand side are equal, I can do anything to both sides. As long as I do the same thing to both sides, it'll still be equal. So if I want the centimeter units to become centimeter cubed, I need to take this entire side of the equation and cube it so that the units will be cubed. But to keep it equal, I have to take this side of the equation and also cube that. So when I cube the left-hand side, my centimeters will become centimeters cubed. What does the 10 to the second power become? 10 to the 6th. So if I have a number to a power and then take that to another power, the powers multiply. 2 times 3 is 6. So I get 10 to the 6th centimeter cubed equals 1 cubed, which is still 1 meter cubed. So now I have a relationship that directly relates to two units I'm interested in. That's the only relationship I need to make that work. So I would start with the given information, and I would multiply that by a factor that's equal to 1. So the whole point of finding this relationship that makes those two things equal is that if I divide one by the other, any two things when I divide will be equal to 1. And since they're equal, if I multiply this 68.3 centimeters by that factor where I put the 2 units on top of one another, it won't change the quantity, it will just change the units. And since I want centimeters cubed to cancel, I'll need to put the 10 to the 6 centimeters cubed on the bottom. And that's equal to 1 meter cubed, so I have to put that on top. When two things are equal, I have to put one over the other. So now the centimeters cubed cancels, since anything divided by itself cancels out, equals 1. So then I just have to put that in my calculator. And when I do, I get 6.83 times 10 to the negative 5th meters cubed.